Hello everyone, welcome back to this channel. So in today's video, we are going to talk about SVM again, that is support vector machine. Like we are talking about support vector machine. So it's a supervised machine learning algorithm which can be used for both classification or regression challenges. So the first question is what is SVM and why we are calling this vector machine? So imagine we have two types of fruits. First one is apple and second is orange. Now we want to train a machine to automatically tell the difference between them. So how will you do it? So you just give the machine some features like weight, color or size. So each fruit becomes a data point on a similar graph. Simply, we are talking about some kind of plotting, that we are just plotting the data in terms of x and y axis, that is known as weight and color. Now apple from a cluster on one side and orange from another cluster on the other side. So SVM is all about to find a hyperplane or similar line in 2D, or it can be a plane in higher dimension that separates the two classes. So for an example, apple and oranges, we are just segregating these 2 points. So let me point out the particular sections. Now, support vector machine. It is basically used in classification problem. So we have apple and another is orange. So we are just segregating through a similar plane that is known as 2D plane. Now, the what makes SVM powerful? Generally, SVM algorithm, we plot each data item as a point in n number of dimension space where n is number of features we have. So it doesn't just draw any line. It chooses the line that it is far for possible from both classes. So the distance is called as a margin point. Let me check. The first line is margin line. So SVM finds the maximum margin, that is best separation, at last better accuracy, to find the better accuracy. So what are support vectors? So the data points that are closest to the boundary line, that is known as support vector. And what are support vectors? Support vectors are all those points are very important just because of uh, to draw some kind of lines and to decide where the boundary lines will be. The real example we can say spam email detection. The number of spam folders, number of spam emails, number of links, and presence of word like free, win, etc. Whatever. So finally, SVM separates spam versus non-spam email. Just draw a boundary between them. So then we just perform a classification by finding the hyperplane that differentiate the two classes very well. So we are just summarizing this slide. SVM is a machine learning algorithm that finds the best boundary to separate data into classes with maximum distance from both sides. So guys, we just move to the next one. So let's continue our discussion on support vector machine. Now we are talking about support vector machine is considered to be a classification approach and it just but can be employed in both types of classification and regression problem. Now we are just talking about SVM. So generally speaking, SVM is mainly known as a classification algorithm. It's very simple. And here the part. Interesting part means it can easily handle multiple continuous and categorical variable. We are saying multiple continuous and categorical variables. It means we just classify the two fruits, apple versus orange. Then regression means predicting price and market, predicting price markets and subject marks, etc. Now, why is SVM is so powerful? SVM is basically it constructs just kind of a hyperplane and in multi-dimensional spaces to separate different classes. So it's all about the continuous data like height and weight and categorical data like yes, no, or it can be your male, female. So you just don't know anything about it, SVM. So we don't have to worry much about the data types. So SVM is quite flexible. Let's talk about the main working data. Main working data means SVM creates something called as a hyperplane. We can say SVM is basically generating some kind of hyperplane in an iterative manner, which is used to minimize an error. So now don't get scared by the word. In 2D, it's just a line. In 3D, it's a plane. Simple. As in simple word, in 2D, it's a line, and in 3D, it's a plane. So that is called hyperplane. But there is a small part. SVM doesn't just randomly create a boundary. It iteratively finds the best possible hyperplane that one the minimize error and gives the best separation between classes. We already mentioned this kind of point. The core idea of SVM is to find a maximum marginal hyperplane MMH that best divides the dataset into classes. So SVM tries to find a hyperplane that has maximum distance from both classes, better generalization, and less chance of misclassification. That's the main objective of SVM. So we can take some real lifestyle like imagine you are separating student who passed or student who failed. So based on number of hours, number of study hours, and attendance, their attendance. Now SVM will draw a boundary line, but just any kind of section we are talking about. So it will choose the line that keeps maximum gap between pass and fail student. So even if new data comes, the prediction will be accurate 100%. So guys, in simple words, SVM is a powerful algorithm that finds the best boundary that is known as hyperplane to separate data while maximizing the margin or minimizing error. So if you like this video, please like and share and subscribe this channel too. So if you want any separate video on any algorithm with coding, so please drop a comment. So thanks for watching.